Welcome everybody to today's webinar. Today with us is Asghar from DataRobot. Asghar, pleasure to have you on board today.
Yeah, thank you. Thank you for having me.
So we're going to talk about automated machine learning with DataRobot, and we're going to specifically discuss a use case around demand forecast, which seems to be in high demand in large enterprises. A few logistics before we get started. So this session is going to be recorded, and the recording is going to be made available within the next 48 hours. In case you have any questions, please feel free to use the chat on the right-hand side of your screen, and we're going to pick up the questions as we go. And we're assuming that this webinar is going to approximately 60 minutes. So Asghar, how much time do you need for the presentation part? 40, 45 minutes, I guess?
Yeah, 40, 45 minutes should be sufficient.
And we would have 15 minutes for your questions. So without further ado, let me hand over to you, Asghar. Asghar, the stage is yours.
Yeah, thank you. For everybody in the call, thank you for taking time and joining today's webinar. Probably the first question that we need to answer is why anyone should attend this webinar and what we're going to learn. And being conscious about the fact, Rafael, that we have probably a mix of audiences today in respect to their exposure to data science, like expert data scientists or business analysts, or probably like data engineers. I see from your community that you've built. And so my purpose is today that I want to talk to all these audiences. Even I would say that it is automated machine learning, which allows this topic, predictive analytics, be accessible to a wide range of audiences, right? And so what today we'll learn is how we can use automated machine learning and how we can use that to apply to solve a business problem. In terms of today's case would be like demand forecast. So how we use automated machine learning to apply it to demand forecast. And we will be using DataRobot platform as an automated machine learning platform for today's discussion. Right, and in terms of agenda, I'll go, present some context, set the scene, and then I'll jump into, what demand forecast is, and a little bit, some high-level overview on time series, and then I'll jump over to demonstration of, how we can use DataRobot solve demand forecast. And yeah, as you said, we're gonna have a Q&A at the end. All right. Before I jump into the discussion directly, I'd like to motivate a little bit, the whole conversation we have by raising this quote from Elon Musk. He basically says, if your competitor is using AI and you don't use that in your business, they're gonna crush you. And even some market research institute going to put some numbers in what that means. How much money is going to be transferred from these companies that not investing on AI to those that investing in AI. We might not agree with, everyone would not agree with all the details. It's 1.2 billion trillion or how much the exact figure is, but I guess at least in this call today, everybody agrees that if you're utilizing the data that our organization is collecting, we're gonna have, we're gonna benefit from that, and everybody's going to benefit from that, and there is no doubt on that. And that's so. And in this point, I'd like to thank again the organizer of this webinar, because that provides a platform to exchange the knowledge and with that to make sure that we are going in the right direction effectively. All right, so demand forecast. So essentially, demand forecast is if we are able to answer this question, right? When we want to do demand forecast, most of the time we want to answer these three questions: what I need, when I need, and where I need. And these questions can be applied to stores, either it's like wholesale, retail, and we want to know what we need in the next few days in that store, what kind of items we need. I mean, how much going to be the sales, and knowing those information, we can do proper staffing. And or in warehousing, we want to do optimize replenishment, or like increasing turnover rates, or reducing holding costs and stuff like this. Or if you're like energy company, energy firm, you want to do like capacity planning and things like this. I don't know, in manufacturing production planning is very dependent on what we are going to what will be demand forecast. And even in travel agencies, this pricing in travel industry is kind of connected to demand, and that they use the demand to optimize the pricing.
Asghar, one question here. Do you see with your customers that you're catering to, do you see any bias in terms of industries or use cases around demand forecast?
So we have in demand forecast, I see from a lot of different companies from the different areas approaching this, but that they are in different level of maturities. What we see in retailers are more ahead than like manufacturing, and yeah. Also, it depends also regional. Some region are more advanced, like so manufacturing in Japan. We see that they are taking off, and they're very good at predictive analytics, and but some other places less so in manufacturing. Okay, so if in following up in your questions, you ask. So demand forecasting is not easy. That's why not everyone is doing it, right? It is challenging, and the reason is that they do a few points. It's like technically it's complex, because demand forecast is basically kind of extrapolation. We look into into the past, and we are looking into the pattern we have in the past, and want to apply that and extrapolate into future, and that's a very challenging thing. And one of the approaches to solve that kind of problem is time series analysis, which as a modeling technique, time series itself is a complex approach. So that one item. And another item is that market condition changing always. So we are living in a dynamic world. So it's not whatever I have today as a condition and I'm building my model, tomorrow it might change and doesn't hold. And due to various reasons, like we have change in regulation, we have competitors' strategies are changing day by day, right? I mean, imagine you have a store and your competitor opening another store close to you. That's going to change. So that basically means that you always need to revisit your models on time-to-time basis. So you always need to build a new model based on in order to capture this, market condition that is changing. Another challenge is the scale. What I mean with the scale imagine if you have a store and you want to do demand forecast for all of your items. So how many demand forecasts you are going to do, and how many, each item has different colors, different sizing. So if you want to do demand forecast for all of them and scaling that and taking into consideration of, market dynamic and those technicality of, time series analysis, you can see that, how, demanding that going to be, how much complex situation we're going to have. And basically that, highlights the need for an automated platform. So with that, I'm going to the next slide, which is a time series. All right, time series is one approach to do or to solve demand forecasting problem. So what time series is like, imagine that plot represents a sales figure. It's, just imaginary shop imagine we have, and that's a, represents the sales in the past. So from 1950 to like now, imagine here is 2004, we have the sales figure. So if the question is what would be the next year's sales, that's what I want to know, right? Anticipate what is the sales next year. And in that case, what time series does is like looking into the past data and figuring out what pattern do we see in data and applying it to future. So as a modeling technique, in comparison to the classic or the usual machine learning approach, like classification and regression, time series has some differences, and that's why it makes it difficult. And with that, I'd like to point out some of those differences, and we see that why time series analysis is a little bit challenging than comparing to regression and some are typical machine learning approach. So now look at this plot. This is again sales data against year we have in different years. Now, what we see here, if you notice, now we have, 2010 here, 1960 here, 2005 here. So there is no order in the year. So in classic machine learning technique, right, like, classification and regression, order of rows doesn't matter. And let's now order this year and see. And let's see what we can see. Okay, now I just ordered this axis of year, and you see that a pattern appears, and we can obviously see a pattern which we couldn't see before. So this this sounds very simple, but that's that's like this principal difference between time series technique, that because of this order we can only see the past, we cannot see future, and we want to only forecast the future, and that's really big difference. And that's basically we see that order of rows doesn't matter, doesn't hold anymore for time series. And another assumption in typical machine learning, like regression and classification, again, is that training and future data are similar. If we look at this specifically in that point, we can obviously see that there is a different, a sudden change here that doesn't represent any pattern that we have seen before. And again, this basically tells that training and future data are similar, doesn't hold, and broken in time series analysis. Another point that I'd like to point out is that in time series, in usual machine learning, like regression and classification, models can be evaluated with a single row of data. That means if we have only one data point, one row, we can do the prediction, or we can evaluate the result of that row using the model. But with this example, I want to show that that doesn't hold. If we look at these two data points here, and we want to know what would be the next value, given if we only know if we only knew the data up to that point. If I knew the data up to that point, if the question was what would be the next point, and if the only information I had was this point, you know, I can see with that point, you know, these 2 points have same values, but their next values are different. So for me, in order to be able to say what is the next values from each of these points, I need to know what was the history data before that point. Like in this case, you know, there is an obvious, downward trend, and this is a good bet from here. If I say that, you know, my next data point would be also a little bit, you know, lower than that and goes with the same trend. And in this case, you know, if I'm looking the data before that data point, I can, you know, approximate that, you know, this is an upward trend, probably is going to continue, and the next point will be a higher value. So what that means I cannot only use one single row. So that's assumption that we have in you know, typical machine learning technique is also broken here. So we need historical data. We need to look back, even if I build a model using entire data. If I want to predict the next value of this, I need to look back again a little bit, you know, before that data point to be able to guess what going to be, or approximate, you know, the next data point, next year's, or if it's next day, depending on what type of problem I'm solving. So in real case, it's not only, I mean, in this plot, again, what we are seeing is the sales, these blue lines, and this orangish color represents advertisement. So in real life cases, it is not that, you know, the sales in the last few days or last year is going to give us a hint what going to be next days or next year's sales, but also there are other parameters playing, like, you know, how much we spend on advertisement. And again, for those parameters and you know, variables, their past data is going to you know, impact the future sales. So we see in this case that, you know, the advertisement spending of the last 4 weeks or 4 weeks ago basically is a good indicator of the sales in this case. And you can, you know, easily imagine if we are in different industries, like, you know, if it's we are advertising for a car, that probably, you know, this time lag until you know, advertisement, you know, like shows itself in sales, it's going to take more than 4 weeks, like probably, I don't know, few months. And or if advertisement is in local, you know, newspaper for a local store, then it could be like few days probably. So in real case, we don't know what is the time lag unless we try out many of them. And we have also a lot of different variables, right? Like in this case, advertisement, but it could be like, you know, temperature and you know, the weather condition and things like this that could impact. So this is, you know, shows that how complex things could go very quickly if we add more variables. If we wanted to look into different different lags, different, you know, how long in the past I'm going to go. And on top of that, depending on what types of time series we have in hand and we need to solve it, there are different algorithms available, different modeling techniques, different approaches. And for each problem, some of these are useful, and sometimes even combination of that. But it turns out that unless we don't try that, we don't know which ones is going to be the most accurate one in many cases. So we need to try many of them and do also a combination of them to come up with accurate modeling technique that solves the problem for us. So this comes again on top of that. So the points that I've mentioned so far, what it highlights is the need for an automated platform that takes care of all those complexity and solve that problem for us. So that's the way that we can scale. That's the way that we can bring to organizations, and we can enable the teams and solve the use cases that we have in our backlog. And in this slide, what I'm going to the purpose of putting that slide up is that what I did here is just grouped the functionalities of DataRobot's automated platform, and we grouped it in automated feature engineering part, which is take care of those lags that I mentioned. How much in the past you want to go and use those information to build features that are predictive for the future values, things like this. And then automated target transforms, which basically if you're doing already working in time series analysis, that there are things like you need to take into account, like the linearity of the model, if periodicity of your signals and that you have in your in your target, and you want to transform those to make it easy for algorithm to build the models, to fit the model. So you need to do some types of transformation to makes it easy for algorithm to solve the problem in hand. And another group of features that we have is like automated model back testing. What it does, it basically what it does is like uses part of the model that does the partitioning data, use part of the model to build part of the data to build the model, and some are part of the data for validation. So if you want to test, how stable is your model, how predictive are your model, how much it generalized, you do these kind of testing. And this is equivalent of cross-validation that you would do in typical machine learning techniques like regression and classification. In time series, you have this back testing. I didn't go into details and discussion today, but this is also one of the things that automated machine learning platform takes into account. And we have it in DataRobot. And last point that also I mentioned was that we have different algorithms, different modeling techniques, and you need to apply many of them to come up, and sometimes combination of them to come up with a very accurate model that are very predictive. So putting all together, so DataRobot provides all these, takes into account all these considerations and tries to build, very accurate models in an automated fashion that we don't need to, handle all these complexities. It takes away, the complexity from user's perspective and makes it, easier for us just to apply, focus on, framing the business question that we have, and and give it the rest of complexities and technicalities to DataRobot to solve that. And that's the idea behind this automated platform.
seems very much like a very convenient way, Ashkar, for businesses to get started with AI who have very limited experience, because it abstracts all the complexity away, right?
Yeah, exactly. That's the point. Exactly. I mean, that's the why. What as I at the beginning mentioned that bringing this point, if organization is not going to be AI driven, how much is going to cost? At least from perspective of those market research institutes. So how then those large organizations is going to be AI driven, like hiring all data scientists, in the world, or there is a limitation. We cannot have all the data scientists in our organizations. We cannot build, all of a sudden, every department has a big, data science team. So what we can, how we can now, scale in those cases, exactly what you pointed out. So that makes it, capitalizing on what we have now. So we have a lot of business analysts. They know how business works. They know, they know their data. And if they want to go to be an AI driven, then they need to have a platform like this that takes away those complexities, and then you can focus only on your business problem, on your data. And these are things that you need. This is your asset, and you want to capitalize on what you have already as an asset. And yeah, start from that point. Exactly, that's the point.
So I'm assuming, Ashkar, that even a business analyst or a data analyst who's coming from the Excel world might actually get started with DataRobot. Is that correct?
Yeah, exactly. And that's what I wanna go and with this demo show that how easily we can build it, do a use case. Let's now use this time that we have to, do a kind of a real case use case. And we're gonna I'm going to show that how we can use DataRobot as as if I'm a business analyst, and do build a predictive model and use that model as well. So that's the objective of building the model and using them as well. So, and what I'm going to do. And so the use case, as already mentioned, is around this demand forecast. So what we will be predicting is the amount of sales in few stores that the few stores we have. So this is the data set I'm showing to you here now. And these are the information regarding the stores we have and their sales. So these are the names of the stores that we have in different cities. I just wanted to show that it is not only one city. So we have different multiple stores, right? And so we are going to predict what is going to be the sales next day or next 7 days. This is the the use case we're going to solve together now. So what else we have here? So we have date column, and as we can see, this is a daily data. So so daily sales of stores that we have. We have other types of information also in this Excel sheet. We have store size, we have number of employees that day in that store. We have percentage of returns, returned items, and some other things like even text data. We have some other data like whether that day was close to Christmas, was close to Black Friday, it was a holiday. There were specific events closed that store and that day, and some are indicators of economy as well, like GDP. So as you can see, we have various types of data. We have categorical data, text data, and numeric data. And we're going to use this information and this data set here to build a predictive model that can predict what is going to be the the sales in the next day or like in next 7 days. That's the business use case that we're going to work on this. So what I'll be doing, simply just loading this data into this the DataRobot platform. Let me go to dataset here, just uploading. Yeah. So as you can see, there are the different ways to upload the data. Some of our colleagues just drag and drop here. I'm not doing that right now, but we can drag and drop simply here. I mean, one of the perspectives is that to make the UI very simple and easy to work with. That is one of the objectives. So you can use more systematic way to connect to databases, data sources, or just drag and drop. So multiple ways to upload the data. So as soon as data uploaded into DataRobot platform, what I need to do is simply say that, okay, what I want to predict. If I remember the name, I'm going to type it here. If not, I can scroll down here, and that says, for example, I found it, and I can make it as a target. But because I know this data set, I'm going to just here select sales. All right, so you can see that this giant button, start button, appears here. I can go start and click that. If it was like regression, if it was a regression problem, or if it was a classification problem, I could have like jump like right away here and click to start. But because it is like time series, I need to like just tell DataRobot what I'm going to predict. And already DataRobot noticed that we have time data in our data set. So it says that, is it a time series? And I'm saying, yes, of course it is. And DataRobot already recognized that I have a column called date with the type of date. So it's asking me, is it that the column that represents the date? I'm going to say yes, is that date column. And it also shows a portion of the data, how it look like my data set here in time. And so what I'm going to do is that using time series modeling and to model, because we can model at different approaches here, like out of time validation, and it's like standard classification or regression, but you have validation that is coming from future data set. But what we wanted today to build a model based on future data and predict 1 day ahead or 2 days in future or like 7 days in future, and that would be like what we want to go today. So I'm selecting that. What DataRobot noticed in telling me here is that are there multi-series in your data? Because it noticed that apparently I'm not going to only do for one store's prediction. Apparently it's multiple variables that I'm going to predict based on data. It recognized that automatically and suggests even to me, which of the columns are the series identifier, which I'm going to choose the store because it's the store that basically I want to predict for every stores we have. Right, so I'm selecting that. So what else I need to say? So if I'm going to do a time series analysis, what business question I have, I need to know that, right? So what I see here in this, 1 and 7 tell me is that DataRobot suggested for me is that like next 7 days, I'm going to predict, but probably if I'm interested in doing like next 6 days, I can do this as well. If I have a business constraint, let's say that, if I know this says tomorrow, I'm not going to be able to do anything today, but I'm only able to take an action, from 10 days in future. So I can incorporate my business constraint here. But for today, I'm going to leave that to their 7 days forecast. Another thing that I can also set up is that, how many days I want to go back and create a feature out of them and use them to predict the future, forecast the future. I'm going to leave that, DataRobot, based on the data set I had, DataRobot suggested me that, last 28 looks good. But if I have a specific constraints, like, this is like to 0 here means like from today up to, past 28 days, which is 4 weeks. If I know that in my business, it takes 10 days for me to get the data, all right, so I'm going to put that into here. So any constraint that my business have, I can incorporate here. But for now, I'm going to leave it as it was. Also, DataRobot told me that it tells me here that you have 10 stores, so you are going to predict for each store. Another thing that DataRobot wants to know if there isn't a feature that we know in advance, like holidays, right? So we know in advance that it's going to come some holidays. We can go here in the list and says those variables that we know in advance, like store size. We know that. If you have like marketing plan, we know that. We have if we are close to Christmas, if we are close to Black Friday, holidays. If there's any specific events is going to happen, we know that. So we're gonna go select them and tell that, okay, these are features that we know in advance. And so if we come back here, we see that now there are 6 variables that we identified as we know that those values in advance. These are known in the future. All right, so I think that we now shaped our business question. So what is that we used data, that we have sales, and some other data we saw, and we shaped that the question in the form that we want to know, what going to be sales tomorrow, the day after tomorrow, until next 7 days. So with that, I'm going to just click the start button, and what I see here is that there's a summary of what information I gave, like last 28 days is going to be used. Information of last 28 days is going to be used to build features to predict, or to forecast the next 7 days. I had 21 original data features, and 6 of them were known in advance, or are known in advance, basically. So what DataRobot now is doing is building, is creating those feature lists, right? And what we see, things like, sales of 2 days ago, or 4 days ago. These kind of lags. It looks here at the sales. How was it? It was 4 days ago. Even things like the difference in the sales, in 7-day difference in the sales, and a lag of 2. So is it that going to be a signal? Creating all those features for me that automatically, that I don't need to create those. Those kind of long lags that we discussed before, all is being are being created by DataRobot automatically. And we see here that DataRobot created like more than 350 new features out of those variables that I introduced to DataRobot. So what else DataRobot does few things, like preparing data, does some characterizing of target variables, and so on and so forth. What important interesting things that it's going to do is that creating a list of models that are going to be built. So it looks into which kind of models, what model is going to be a good candidate for this data set, and chooses those those models in order to feed and those models into data, and building those models that are predictive and good enough. So in time series analysis, we always, in order to be able to say that how accurate my models are, I need a baseline. I need a reference value to look at that and say that now how good I am in comparison to that. So now what DataRobot does now exactly is that creating those baselines. And those baselines are going to be a reference for me or for DataRobot to compare our new models, that how, if a new models have been built, how accurate they are going to be in comparison to them. And those two baseline DataRobot has chosen based on the periodicity that we had in dataset. Like, this baseline basically says that if I'm taking a 7 days ago's value sales and predict for today, that's the baseline. So for that case, so that means that if how was sales last Monday, I'm going to predict this Monday going to be the same. So that's a very naive predictor, and this is going to be a baseline. So when we want to know how better we are going to be with that baseline, and DataRobot does that for us. So we know we don't need to do all these comparisons. So these are the workers that DataRobot does. That means that we can have even more workers. That means like more parallelism, which means like we can build models quicker. I just increased it to 20, which means now we have 20 workers that are working in parallel to build and fit data, fit models to data. And this is the leaderboard, and this compares the model with each other, and the most accurate ones is going to appear in the the top, and the least accurate goes down the list. So in order to save time, I'm jumping to a finished project that we can go a little bit quickly, being conscious about the time. So this is a finished project, and we see that if I'm going to the baseline here, which must be sorted down here, or like this one, and comparing to that baseline, this model, you see the most accurate one is like 45% more accurate than the baseline. So that means that we are like almost 2 times. Now we have DataRobot built for us a model that is 2 times more accurate than naive predictors of what was the sales of last week. Now I'm going to predict this week is going to be having last week's sales. Comparing to that, we are 2 times better. So that justifies that now we are basically need this model to use if you're going to do staffing that have some return on that. So what else I can like mention here is that we call these blooping. So that means that we are transparent. These models are not black box. You can see what's happening in building these models. So it's basically is a workflow from data, different the data is placed into different depending on these types of categories that data have, like is it text, numeric, or categorical data, and they go forward into our the modeling, the machine learning algorithm to build the model, and finally predicting. And also they are very good documented. If anyone wanted to have more details on that, even references, you can go and see. And we can also go and see what our model says about those predictors, those variables that has been built. So what basically drives these models that has been built. So like in this case, the most important variable turns out to be that the last 7 days average, and this going to be like this is a very good indicator of sales this week or today, tomorrow. And holiday turns out to be a very good indicator. Day of the week, is it Monday or Saturday? That's a very good indicator. Or if it's near Christmas, and these kind of information can be seen here, and gives us a transparency that what drives these models, what drives the sales for next week. What is important indicators, and we need to focus on those if they are actionable. And even I could see accuracy over time. What are the trends that my models built in comparison to what reality was, actual data. I can see those here. Now we can see stability, how by the time it goes, how my algorithm is acting. We can see the forecast accuracy. This is the accuracy of next day. This is accuracy of the day after tomorrow. This is like 7 days out from now. It just confirms our kind of intuition, right? That the more we go out in future, the accuracy kind of diminishes a little bit. But still, even if you're like going to predict 7 days from now, we are 30% more accurate than baseline. So still, predicting 7 days from now using these models are, in this example, shows that there is some return and makes sense to use that model. Now that we build our model and we investigated that, now is the time, because our objectives is not just to build the model, but to productionizing that, and that's the whole thing, right? You want to use these models into your make decisions, or do some action based on the information that you get from these models. And that is also one of the important aspect of this platform, that we want to be all the models we build, wanted to prepare them and make them in a situation that we can easily deploy them and use them. And that's so there are a few ways that we can use our models. One way, simply here, and if I have an Excel file or a CSV file or anything, I can in batch prediction come here and just upload my data and get prediction. And I can also see, okay, how does it look like for this shop, or for my other shop in Richmond, how that does the prediction looks like. So that kind of information I can get here, and either download or just preview the prediction. This is one way to do it. Another way is that I can even deploy my model in a deployment server and expose REST API. So any application that are able to use API, like if I'm I build an application and I want to integrate and use that application to do the prediction and automate the whole platform, and the whole thing. After building my model, this provides a way to do that. So you deploy it, and you get an API with credentials that you can then use that to use REST API to send your data and get the results back from that. And that's one way to do it. And if you have other applications, then you're not bound to one language. If you're a fan of Python or JavaScript, just writing a web application, and you want to enter the data in your web application, and that send the data to the this prediction server and get the results back. That would be one approach to do. So to wrap up, and basically what we did, and uploaded data in the platform. We shaped the business question we had in mind, and framed it in DataRobot platform, and push the button, and DataRobot basically build different models and compare that, with each other, and prepared the model for us for deployment. And we went and deployed these models, or at least the one that was a favorite. We wanted to deploy and deployed that. So with that, I want to conclude, and I think that now I'm open for if there is any question, and discuss those points.
Thank you so much, Asghar, for this presentation. And we actually have one question, which is actually multiple questions in one. So let me read it out for you in the first place. I have tons of data. When and how can I use DataRobot? I work for Magenta TV and would like to use the tool ASAP. And there's another question coming in from the user, which is data security and privacy already clarified and approved? So let's split up those questions and walk through them one by one. So tons of data. How can you actually automate the process of running your data through DataRobot in an automated fashion at scale? And I'm assuming that many of our attendees today are working in large corporations. So what other deployment scenarios do you guys offer to large enterprises that are highly regulated?
Yeah, exactly. I mean, great question. One thing that I'm gonna start with that. This is a platform for enterprise. So definitely, we're gonna, it's built to handle those cases, and these are the questions that quite often comes to us, and they're legit questions. In terms of data amounts, this is, as you already see, we have parallelism, and with things that we didn't discuss, we didn't went into it details, and maybe even that, these are good points that we can get a follow-up and have more detailed technical discussion. But what I would say in a high level, we have different ways of installation. It depends on the platform that we are installing. How big is the platform? And there are various parameter here. DataRobot, obviously, the limitation of the platform that you're installing. If that able to handle large the amount of data that going to be handle large amount of data. One thing that I didn't mention is that a lot of functionalities that you'll see here that I ran through in the UI are able also an API for that. So that means you can use those APIs and integrate and automate all the things that you saw here. So you don't need to go and click every part of it. So you can basically use those APIs if you wanted. I can need DataRobot Python. This is Python. We have R. You can we have Python APIs and R APIs. You can use those to as one of our colleagues points it that way. You can remote control all the things that you saw now here. So that's one way that specifically those kind of APIs is fitting large organization if they want to automate all that. Those APIs provides really good functionalities that they can get all automated, and they don't need to go through a web UI. And in some cases that specifically for time series analysis, I already mentioned that you have this market dynamic that sometimes you need to build models very quick, quite often. So in those cases, you can automate, I don't know, build models every 1 hour, or every half an hour, or every day, depending on what you need. And those one way to do. And the second question, I think it was that security. Definitely. I mean, if we were not securing now, you can go some of our customers that are referenceable are available in our website, and anyone can go to the website and see that the customers that we are already having. There are large enterprises that I cannot name it here all of them, but they are enterprises that security is the number one thing for them, and if you don't play security well, they wouldn't be even coming close to that platform.
Can you just drop a few names, just 2 or 3 companies that you have on top of your mind?
Because I didn't prepare, I just fear that I reference a customer that is not referenceable in order to. But these are the customer are referenceable, are available in our webpage. They can definitely, everyone can go and see. Yeah.
Okay, so let's get to the next question, which is oh, by the way, feel free to ask questions if you have any. I know that a lot of our attendees are from Germany, so in case you feel more comfortable asking in German, feel free to do so. I'll translate your question. So the next question that we're having here is, how can I get started using DataRobot? I'm assuming that for someone who would just want to get his hands dirty, it would be feasible to just sign up and upload data and just play around with DataRobot. Is that the case?
Usually we need to the best way would be to reach out and to DataRobot, and we definitely come back and follow up on that, and we find the best way that we can find what would be the best way, because the case to case is different, and we need to a little bit get information how we can go forward from that. And if you like following up, just reach out to me or our colleague from our website, or just drop here. If you're interested, we definitely follow up on that, and we find a way to how we can use it. What is the best way to use the DataRobot, because we provide a lot of support in that, from education, from even education in data science. We have DataRobot universities. Maybe it's not a bad idea to just DataRobot university. We have university for data scientists, for business analysts. If you're a business analyst and you want to a little bit go to up to speed, for executives, and these are different ways that we approach with different teams. And the best way would be that just simply let us know if you're interested. We definitely come back to you and find the best the more effective way to work. Yeah.
Asghar, one question regarding data preparation. What capabilities do you offer to users, or do you expect the data to be already cleansed and prepared in order to be able to work with it in DataRobot?
No, definitely that doesn't need to be cleansed. You can see here, DataRobot handles different data prep for the algorithm that comes at the end. There are functionalities that baked in DataRobot and does those kind of feature engineering that are needed. And you already saw that at the beginning that DataRobot created 350 something number of features out of the data we provided, and we had we given to DataRobot. So a lot of these kind of if we have null values and things like this, DataRobot goes very well around that and finds the based on best practices what would be the best way to deal with that. And however, data needs to be in a flat format. So if there is a specific joins, that needs to be done outside of DataRobot. And because I need to mention that the DataRobot is a very machine learning platform, so we are focusing on that. But we have a very good community around this. So we have a partnership with very with those ETL tool providers that basically, we can work very well with those ETL tools, and we can, leverage what already existing. Yeah. Hope that answered the questions.
Sure, absolutely, absolutely. So we are running out of time. We just have 1 or 2 minutes left, so it's time to wrap up. So for all of you guys who joined us later, this session is going to be recorded, and we're going to send out an email within the next 48 hours so that you can either review or maybe share this recording with your colleagues. And we're also contemplating to maybe host a session in German. Like I said, we are having many attendees from Germany, and you might want to invite customers or partners. And as we know, Germans feel very comfortable getting information in German, right? So,
Yeah.
so just for the record, we're contemplating to have this in the future. So with that, Asghar, thank you again very much for hosting this session today and for giving us insights into how DataRobot is working. Thank you everyone for joining this session today, and hopefully see you soon. Bye-bye.
Yeah, sure. Thanks. Bye-bye.